Back to those who were with us yesterday, as well as all the new attendees joining us today. Today is the second of 3 sessions which kicked off yesterday. Over these 3 days, we're focusing on energy-related aspects of the circular economy with a 90-minute session each day, packed full of insights from a wide variety of sectors. So do be sure to tune in tomorrow if you can. I'm Michelle O'Sullivan, Chair of Energy Cork, and I'm very pleased to represent the membership and the steering group of Energy Cork in welcoming you all online this morning. As ever, Energy Cork and events such as this wouldn't be possible without the ongoing support of Cork County Council and Cork City Council through their respective economic development funds. And we're delighted to have Cork Chamber as the conference sponsor this year, and we thank Cork Chamber for the support in bringing this conference to you today. Delivering our Energy Cork conference is a big undertaking, even online, and the cluster is indebted to our steering group, especially our conference subgroup, for their help in putting this together. We're particularly thankful to all of our speakers and moderators who've committed to participating over the three days. We'll meet today's group shortly, and you can check out the full lineup with speaker bios in the conference brochure, which should be popped into your the chat box shortly. Firstly, a few items of housekeeping. It should already be done, but please, if you could keep your microphones on mute for the duration of the event. We'll have a Q&A session following the presentations. Please use the chat box function to ask any questions you might have. We can't promise to get to every question, but we'll absolutely do our best, and we can always follow up afterwards if required. Today's event will be recorded and made available in due course afterwards. You'll be introduced to Harry O'Farrell, Vice Chair of Energy Cork, later in the session, with Harry closing on today's proceedings. Our session yesterday was focused on turning waste to energy. Today's session focuses on the circular economy in practice, buildings, transport and heat, and I'm very much looking forward to the discussion today. With tomorrow's session, the circular economy and the just transition, very importantly, to which we sincerely hope that you'll be available to join us for that discussion tomorrow. And so I'm delighted to introduce our moderator, Val Cummins of Simply Blue Energy Kinsale. Val is a member of the executive team in Simply Blue Group. She is responsible for the Emerald Floating Wind Project as Managing Director of the joint venture partnership with Shell. She has a distinguished track record in the development of marine renewables during her tenure in University College Cork. Val is an Eisenhower Fellow and has participated in Women in Leadership Executive Training at Harvard University. So again, we're in very good hands for today's session. Thank you, Val, and over to you there.
Thank you so much, Michelle, for the introduction. It's absolutely brilliant to be here for the Energy Cork conference on energy and the circular economy. Today's session is going to focus on the circular economy in practice. And just thinking about this, it occurred to me last night that I think the first time that the topic of the circular economy came to my attention was via an absolutely tremendous lady called Ellen Macarthur. She set a record in 2001 when she came second in the Vendée Globe race for sailing single-handed non-stop around the world in her yacht, the Kingfisher, and subsequently set incredible records for circumnavigation of the globe with a record in 2005 of 72 days at sea alone with incredible resilience. The reason I bring her up, though, is because when she was at sea, she was inspired by the vastness of the ocean and the power of nature, and she became a really passionate conservationist. So when she retired from sailing in 2010, she established the Ellen Macarthur Foundation to accelerate the transition to the circular economy. So just by way of a bit of context, the Macarthur Foundation defines the circular economy as number 1, designing out waste and pollution, number 2, keeping products and materials in use, and number 3, regenerating natural systems. So this morning, we're joined by other inspiring leaders in their respective fields, each making waves in their own right in the energy and the circular economy arena. I think this session is richly diverse. It will showcase energy and circular economy initiatives in district heating, in the built environment, in transport, and in electricity case studies. And we have 4 fantastic speakers. We have Donna Gartland from CODEMA, Niall Crosson from Ecological Building Systems, Mario Pagliaro from CNR, and Ciaran Gallagher from ESB. So each will speak for 10 minutes. I'll introduce each speaker before their presentation. Questions are welcome in the chat, so please be free and feel free and do use the chat. We'll monitor the questions as they're coming in and endeavour to bring your questions to the panel in the Q&A sessions after the talks. So without further ado, I'd really like to introduce to you all our first speaker. Donna Gartland from CODEMA is the CEO at Dublin's Energy Agency, as well as being CEO and co-founder of the Irish District Energy Association. She holds a BEng in Energy and Environmental Engineering and an MSc in Sustainable Energy Planning and Management. Donna has been working to develop the district heating sector in Ireland for the past 7 years, looking at solutions to overcome the current knowledge, legal, regulatory, policy and financial barriers. She's working with local authorities in Dublin to develop the first large-scale district heating schemes in Ireland, namely the Tala District Heating Scheme and the Dublin Docklands District Heating Project. She is on the department's District Heating Steering Group and the Steering Committee of Renewable Energy Ireland. So Donna, delighted to welcome you and look forward to hearing your talk.
Thanks very much, Val. Thanks for the introduction. So I'm just going to share my screen and hopefully this all works out well. Ciaran, Val, you might just let me know if you can see that okay? Yeah.
All good. Perfect.
Yeah, so 10 minutes is going to be a hard step, but I'm going to have to jump straight in here. So what I'm going to do is chat about the role of district heating in the circular economy. I always have to start off with the first slide, which is what is district heating? So the reason I have to start off with this slide in Ireland is because it's not a very well-known technology here. And we don't have it contributes to less than 1% of our total heat demand in Ireland, but it'd be very well known across Europe. So what it is an underground network of highly insulated pipes which transport hot water to buildings. So if you think about it, it's just like an electricity grid but for hot water. So it's underground, the energy is delivered to buildings, it's metered at each individual building, and you pay for what you use. So just like an electricity meter, you have a heat meter instead, and you have on-demand hot water and space heating from the network delivered to your home or your business. As I said, this technology is quite new to Ireland, but obviously very well known across Europe. And I'm sure Mario, who's also on the call today, will know a bit about district heating. There's a lot of actually district heating schemes in Italy. But it just hasn't really taken a foothold in the Irish market or really in the UK market either. So we were kind of the last to the district heating scene. So it is widely used across Europe. It's not just for cold countries. As I said, like just schemes all the way from the very south of Europe up to the very tips of Finland and Sweden. And these schemes have been around since the first district heating scheme was developed in Denmark back in 1910. So well-established technology, and it's well proven. So how does it relate to the circular economy? So when we talk about district heating systems, we often talk about utilizing waste or excess heat. And what I mean by that is, and we're going to take the direct definition from the EU Renewable Energy Directive. So it's heat or cold which is generated as a byproduct in the industry or territory sector, and which would be dissipated unused, so thrown away into the air or the water without access to a district heating network. So obviously building a pipeline down to your local power station just to connect your own household is not going to be very economically viable. So you need a network with multiple buildings connected to the pipeline to make use of this. So you have the economies of scale there to make use of this technology of this waste heat. So where does this waste heat come from? We have different types of waste heat. There are high temperature waste heat sources. So they're typically above 80 degrees Celsius. So directly usable hot water that's currently going to waste from things like cement factories, from power plants, waste energy plants, from gas refinery plants, and from large food production or distilleries. So all of this is, it's kind of quite visible because it's high temperature. So on cold days, you can see the plumes of steam coming from chimneys, for example, but also you don't see what's I suppose this is cooled through water sources, local water sources. So it's also dissipated to local rivers and nearby water sources. So they're the kind of high temperature sources. We also have low temperature waste heat sources, which are also usable. So these will be in the range from 20 to 40 degrees. So if you think about it, even though your gas boiler might deliver 70 or 80 degrees to your heating system, the actual space heat that you use, the temperature you want in your house is usually around, it's going to be around your, maximum 25 degrees. So, I mean, for new builds, for retrofit buildings, this is very directly usable for space heating, but needs to be boosted up obviously for hot water use. So the kind of sources then for this are things like data centers, and would have a large amount of waste heat from data centers, wastewater treatment plants, electrical transformer stations, and cold storage. So these are just some examples. And there's a good European project called Reuse Heat. So if you go into reuseheat.eu, it kind of gives you a larger list of all these different temperatures or different sources of heat available at the different temperatures. And I suppose one of the advantages of lower temperature as well is they kind of tend to be quite close to urban heat demands as well. So obviously the sources have to be within the range, close by to the demands for the buildings that you're going to be supplying. So I suppose in terms of circular economy, this is a big issue at the moment. We're using this. The only people that are making use of this are the birds and the fish. So particularly in the cold spell like we're having at the moment, those guys are enjoying it a lot. But if we can try and make use of this, we can obviously offset our own fossil fuel use, our own gas use, our oil use for heating. So if you want to understand, I suppose, where these sources are in Ireland, there are some good resources available. So the Irish Heat Atlas, which is available at districtenergy.ie, shows you the conventional excess heat active sources. So these would be your kind of high temperature, large scale sources, which would be industrial excess heat, waste energy plants, and power plants. So you can go on there and you can see where those sources of high grade waste heat overlap then with areas with high density heat demands, which would be highly suitable for district heating rollout. So I suppose where those areas overlap are, I suppose, the kind of high suitability areas. And you can see there Cork obviously has a couple of large scale sources of waste heat from power plants, and then the Cork area, and obviously large heat demands within the city region as well. So being the Dublin Energy Agency, obviously we've done a bit of work, kind of further work in the Dublin area, and to kind of look at the larger the wider waste heat sources that are available. So not just your large scale power stations, but also all the other sources I spoke about, such as data centers, wastewater treatment plants, etc. So on that map, the bigger the symbol, the larger the energy, the waste heat that's available from that source. So you can see the big red dots there, they're the data centers. So obviously data centers represent a big source of waste heat, particularly around the Dublin area, where a lot of them are located. Power stations, wastewater treatment plants, those guys would all have very large amounts of waste heat available. So, we've estimated that, we've enough waste heat available in the Dublin region to heat about 1.6 million homes. So, I mean, this is something that's being thrown away. We talk about circular economy, just because we can't see it, it's not as evident as plastic bottles or anything else that's being thrown away. This is being thrown away to the air and to water, and it's I suppose it's been largely ignored in our energy policy up to now. So why we're looking at waste using district heating particularly is because obviously it can be used to recycle this waste heat through the pipelines. Importantly, what district heating offers is thermal storage. So thermal storage is basically big giant hot water tanks. So if you can imagine the one in your hot press at home, but multiplied by a few thousand. So a large hot water tank is the cheapest form of energy storage available. It's a steel tank with a bit of insulation around it. This can then be used to utilize the waste heat at different times. So if you don't have demand at the time when, say, the local cement factory or the local power plant is producing the waste heat, it's stored in these hot water tanks and used during the week or over the next few weeks then to supply that demand. So you're able to utilize, I say, more of the waste heat that's available. Also importantly, that the thermal storage allows integration of curtailed renewable electricity. So I suppose curtailed renewable electricity is when the your renewable generators, such as large wind or solar generators, are asked to dispatch down. They're asked to turn off because there's too much renewable energy on the grid. And this is essentially another form of waste energy. This is wind that's blowing, the sun is shining, and we can't utilize that electricity. So again, we can utilize it in the heating sector through large-scale district heating systems by utilizing it in large-scale heat pumps and electric boilers. And obviously all of this offsets the CO2 and the fossil fuels used in our heating sector. So in practice, how are we doing this? So as Val mentioned, we're working on 2 schemes. So I'm just going to highlight one of them today, which is the Tallaght district heating system. We're also working on another one which utilizes waste heat from the waste energy plant in Poolbeg with Dublin City Council. But the Tallaght scheme is quite innovative in that it's using the kind of lower temperature waste heat source from a local data center. So a data center was being extended in the Tallaght area, and we saw this as a great opportunity. We've been planning to kind of do something around district heating in Tallaght, and we got European support through an Interreg Northwest Europe programme, and we were able to progress that project with Dublin, with South Dublin County Council driving that project. So you can see here a little image of the nice energy centre that is being built in the next 6 months. And the pipes are just being delivered now, thanks to the few delays thanks to Brexit, but they are now on site. So this scheme is currently being rolled out, and the technology, so the waste heat source, obviously the data center, that's given us waste heat input of about 25 degrees Celsius. We're connecting to existing buildings in the first phase. So obviously we have to boost that temperature up to supply those existing buildings, which will have high temperature requirements. So we're using 3 two-stage heat pumps, which bring that 25 degrees Celsius temperature up to between 70 and 85 degrees, depending on the time of year. And obviously having that 25 degrees in, it makes it a much more efficient process than using, say, ambient temperature, air temperature in a heat pump. So that's a practical example of how we're utilizing waste heat in Ireland, and hopefully this will be the first of a long of more pipelines and projects to come forward, and hopefully some starting in Cork in the near future. Thank you.
That was brilliant, Donna. Thank you so much for an absolutely passionate and really interesting presentation. Just learned so much from that, and loads of questions, as I'm sure the audience have too. So gentle reminder to make sure to use the chat, and we'll start capturing your questions for the discussion with Donna in a while. I look forward to coming back to that. What we'll do, we'll move on for now over to Niall Crosson. I'm delighted to introduce Niall. He's the Group Technical Manager with Ecological Building Systems. He holds a degree as a Bachelor of Technology and a Master's in Engineering. He is also a certified Passive House consultant and a board member of the Irish Green Building Council. Niall has provided guidance on several national standard committees and provides input to several working groups with the UK Centre for Moisture in Buildings. Over 18 years, his experience in the area of building physics, energy conservation, hydrothermal analysis, air tightness, natural insulation, and breathable constructions. So fantastic track record, and I'm sure another great presentation. So without further ado, over to you, Niall.
Thank you, Val. I think that's my 10 minutes up with that introduction. So I'll just briefly introduce our company, Ecological Building Systems. Those of you that aren't familiar with us, we're based in County Meath. I'm a proud Cavan man myself. Our company was a family-based business established in 1906. Our parent company is called McCann & Byrne, and over a century it evolved. We import conventional building materials, McCann & Byrne, but in the year 2000, the company, with great foresight, saw significant growth in the continent in the supply of natural insulation materials. And I joined the company around the year 2000 when it launched, and since then we've grown substantially, with offices now in the UK since 2007. So we've partnered with companies that manufacture natural insulations from wood fibre, hemp, cellulose, and other innovative air tightness systems. Our core focus is really on health, well-being, and supplying the market with more sustainable materials. But a core part of what we do is training and education, both for specifiers and for builders as well, in our training centre, both in the Midlands in Ireland and in the UK. So my presentation today, it'll be a whistle-stop presentation. I'll be speaking in relation to the Irish Green Building Council and some of the work we've been doing, and also about the industry as a whole in terms of bringing carbon upfront in the construction industry and trying to tackle embodied carbon in the construction industry. So if we look at embodied carbon in the construction industry, a guy called Anthony Pack, who I have a lot of respect for and I've read a lot of his papers, calls it the blind spot of the construction industry, and for very good reason. According to a paper from Architecture 2030, between now and 2060, the building industry is poised to add 230 billion square meters of new construction worldwide. And this means we will double the amount of buildings we currently have on the planet in the next 40 years, a huge increase. This, to put this in perspective, we're going to be building another New York City every month for the next 40 years. And embodied carbon will be responsible for almost half of the total new construction emissions between now and 2050. So if we're missing the embodied carbon, we're missing the point. It's crucial not only to look at operational energy. Operational energy is important, but we also have to look at the materials we use to build within the construction industry to really tackle climate change and reduce our environmental footprint on buildings. So just to put that visually, this is an illustration from the Wood for Good campaign, which shows an actual building in London called Brideport House. This is a block of apartments, which is built using a construction method called CLT, or cross-laminated timber, instead of using concrete. And whereas concrete would emit at least a kilo of carbon for every kilo produced, this CLT absorbs a kilo, sequesters a kilo of carbon for every kilo used. And as a result, by using a more sustainable building material, this building sequestered over 1 million kilos of carbon within the building fabric. This is even before it's heated. So this should just illustrates the impact our material selection can have on when we build. And in terms of insulation materials, now more than ever, there are many more sustainable alternatives available, which have a circular life cycle, such as hemp, for example. This particular product is called thermo hemp. It's grown in Germany and it's manufactured. Basically, the raw plant is separated in a decortification plant where the seed, the bast fiber, and the shields are separated, go off to various industries in the form of insulation. The bast fiber is taken, manufactured and used, insulated in homes, and for every cubic meter of hemp manufactured, it sequesters 13 kilos of carbon. So by using this material, you're locking the carbon into the actual fabric rather than emitting carbon. So there's a carbon negative a footprint, and then it can be recycled at the end of life. And in terms of our input, whether you're listening as a designer, architect, or engineer, you have a significant effect on the actual carbon, the upfront carbon emissions on a building. And if we refer to this illustration taken from the World Green Building Council's report on bringing carbon up front, it shows at the design stage, if we build clever, we optimize material usage, and with low carbon materials, you have a huge impact on reducing the potential carbon emissions of materials in a building. Of course, if we build nothing, that is the most efficient and environmentally benign way of building, but we have to build. But it's at the design stage, by building less and by building clever, at the design stage, we have most influence. At the construction stage, of course, we can build more efficiently, and in terms of operation and maintenance, there can be steps taken. But crucially, it is at the design stage where we can help to reduce these upfront emissions. And in terms of insulation, we can see the huge variety of insulations and the kilograms of carbon emitted, depending on the type of insulation used. So we can see from XPS to open and closed cell foams to expanded polystyrene to natural insulation materials ranging from wood fiber, hempcrete, cork, and so on. These materials are carbon sequestering. So the most efficient in terms of an environmental impact in many ways, in terms of performance, of course, we need insulation to reduce our energy demand, but the materials we use, we can see clearly on this illustration, the environmental impact they can have. So if we're trying to reduce the carbon emissions of buildings through operational energy, the most impactful way in terms of thermal insulation selection in many cases could be to also use an insulation which isn't emitting such large volumes of carbon in the first place. Here we have examples. This is a passive house being built using natural fiber insulations, and there are numerous of variations around the country of NZEB and high performance buildings. In this case, it's using Gutex wood fiber on the outside of a roof. And this is a very happy insulation installer in this project. Here we see this is delivered to my own house, actually, which is built recently. And every bag of this is made from wood fiber. It's blown wood fiber that went into all my walls. And every single bag on that lorry is carbon negative in terms of its life cycle assessment. And this brings me to environmental product declarations. And environmental product declarations are becoming more and more crucial in our material selection, especially for designers and specifiers. And for manufacturers, environmental product declarations are more and more becoming the norm. And for manufacturers, they can gain a competitive advantage by publishing an EPD because it produces documented and certified proof of the environmental impact of their product. So it tries to take out the greenwash and allows specifiers to analyze materials and compare like for like. And it also assists companies to adhere to their company mission and provide more sustainable alternatives. And then specifiers can also earn points by utilizing EPDs in buildings using rating systems such as BREEAM, LEED, or the Home Performance Index in Ireland. And implementing an EPD in the marketing strategy also, this helps communicate a product's environmental benefits. And the EPD can also help improve supply chain development within manufacturing processes. So the manufacturers that get an EPD, it supports the ISO 14001 standard, and it allows the company to improve their manufacturing process. And it's also very effective for benchmarking and increasing visibility. So here are some example environmental product declarations just on a few materials we supply. This is Dyson Cork lime insulating plaster for renovating buildings. An EPD, these are EPD documents for Gutex wood fiber, blown or rigid batt. And this is an EPD for calcium insulation boards for renovating buildings. And on this website, epdireland.org, it's a central database developed by the Irish Green Building Council where you can log on and download EPDs from a whole array from many, many manufacturers. So there's a central portal that the specifiers can now review and then make selective and informed decisions about what materials they use in buildings and specification. In the built environment in Ireland, it influences over 50% of Ireland's carbon emissions. So really looking at the raw materials we're using in buildings is the next step to really realizing low carbon buildings. This is the report from the World Green Building Council. I'd highly recommend bringing embodied carbon up front. And I just took some main points from it in terms of their definition. Net zero carbon, embodied carbon should be pursued as part of a whole life cycle approach to carbon reduction that includes net zero operational carbon. So a net zero embodied carbon building, new or renovated, or infrastructure asset is highly resource efficient with upfront emissions minimized to the greatest extent possible. And I think that's absolutely key. And it's something we need to realize more and more as we renovate and as we build going forward. And by 2030, all new buildings in terms of their vision and infrastructure and renovations will have to be at least 40% less embodied carbon with significant upfront reduction. And by 2050, new buildings and infrastructure and renovations will have net zero carbon, embodied carbon. So this shows that it's very ambitious, and with the new government announcement this week, I think this should form a central part if we really are going to seriously impact on our carbon emissions in buildings and in the built environment. Just to give a figure relative to Ireland in terms of embodied carbon in buildings and some rating tools. This is some documented information I received from the Irish Green Building Council using one-click life cycle assessment software. And it analysed carbon emissions from buildings in Ireland and the UK. It took 12 apartment developments in the UK and Ireland. And the embodied carbon ranged from 355 to 2,600 kilos per carbon per square metre per home. So that's an average of over 900 kilos carbon emissions per square metre. And to put that into figures, this embodied carbon, it's equivalent to 114 years of operating energy based on the current NZ standard. So it's an awful long time to pay back that embodied carbon. So you could have a low energy building, but you could have high upfront carbon emissions. And one Irish apartment actually had an impact of over 1,500 kilos carbon per square metre, which takes almost 200 years equivalent in operational energy. And the figures provided for Nordic countries, they averaged much lower, down to 365 kilos CO2. But what this shows is the huge potential for improvement to tackle the carbon blind spot that we have in the construction industry. In Ireland, we have significant upfront carbon emissions in buildings. And in Ireland, we have new benchmarks, such as the Home Performance Index, which is a very useful tool from the Irish Green Building Council. It can be more information can be found here on the website. And this discourages oversized homes, sets out zero carbon definitions aligned with International Living Futures Institute. It also encourages the use of EPDs in construction waste targets, and also starts integration levels reporting methods. So it's a very robust rating tool. In fact, in Cork, one of Ireland's first Home Performance Index Gold buildings was built by architect Wayne Moorhead with John Moorhead Architects, and it used natural insulation in Douglas in Cork, and it also has the Gutex wood fibre insulation within it. So it's a good example of a good case.
Just 1 more minute, Max. Niall.
So, thank you.
Oh,
so
perfect.
Summarize.
Yeah, perfect.
EPDs, they provide a fully transparent information to reduce greenwashing, and it's a source for materials ingredients and their life cycle. They will lead to greater transparency. So EPDs going forward are key for the decision-making tool for specifiers. And the development of EPDs will encourage manufacturers too, and put pressure on them to reduce waste in their supply chains and improve efficiency. Material choices do have significant impact on upfront carbon emissions in buildings, and insulation choices greatly affect the carbon footprint of a building in terms of embodied carbon and operational emissions. So insulation can either be a significant contributor to embodied carbon footprint of a building or a carbon sink, depending on the choice. Materials such as wood, straw, clay, and hemp, cork, and so on, these are naturally sequester carbon. So using these materials can help reduce upfront carbon emissions. And finally, this is a quote from on Tuesday this week at the Building Life meeting with the Irish Green Building Council. Mary C. Donnelly, director of E3G, said, "We don't have the luxury to wait until 2030 measuring embodied carbon. And measuring embodied carbon is urgent." And thankfully, this is now we see the architects declare, engineers declare, and also chartered surveyors declare now a biodiversity and climate emergency. And this is rewarding to see and encouraging for the future. Thank you for your time. And that's me done.
Thank you so much, Niall. That was really comprehensive and absolutely on the ball in terms of the topic. We've learned an awful lot and looking forward to it. I know there's questions coming in. I'm keeping an eye on the chat and looking forward to picking up on some of the issues that you've raised, and in particular trying to get an understanding as to the status of where we are in Ireland and how we might be able to ramp up with some of these initiatives going forward. So look, we've heard from Donna in relation to the need for district heating to keep our homes warm, and from Niall in relation to the opportunity to be smarter about how we insulate our homes, all of which we need on a cold, wet day like today. We're going to shift gear now and go to somewhere hot and sunny. So we're going to be joined by Mario Pagliaro, who's in beautiful Sicily. So the next presentation is from Mario, who is in the Research Council in Italy. He is a chemistry and energy scholar. He leads a research group focusing on nanochemistry, solar energy, and the bioeconomy. He ranks in the top 2% of world ranking scientists in all fields of science, and is amongst Italy's most cited scientists in nanotechnology, materials, and organic chemistry. So that is a seriously impressive CV or bio to read out, and looking forward to this presentation, shifting gear to something different again in relation to the circular economy of the lithium-ion battery. So over to you, Mario. Thanks a million.
Thank you. Can you hear me?
Perfectly, yeah.
Thank you for the invitation. I will go quickly. The topic of my talk today is the circular economy of a new storage technology, which is called the lithium-ion battery. Yes, I'm a chemist and working in Sicily. Outlook for my talk today will briefly fresh information on this new technology for electricity storage and some insight on the information crisis concerning new energy technologies. So in two years ago, we wrote an article in which we cited the fresh data concerning recycling and reuse of lithium-ion batteries. The real percentage was 58%, so more than half of the whole output of end-of-life batteries, but reputed scientific journals and also the general press were writing that the rate of recycling was less than 5% in Europe and something like that in the rest of the world. So in that paper, we wrote that the circular economy companies recycling lithium batteries would shortly uptake new green chemistry processes, therefore using new green chemistry technologies. 2 days ago, we are in Singapore, a local company called TSNM inaugurates a new recycling plant, daily capacity of 14 tons per day, which means roughly 4,000 tons per year. And the output is battery grade cobalt and lithium in the form of cobalt hydroxide and lithium carbonate as the main products, not only, but the main products. This is the inauguration 2 days ago. So have a look at the technology. It's very simple. So you first collect the batteries, and you have to produce this black mass from which all the relevant metals are isolated. In order to do that, you first undertake shredding of the batteries, separate with the magnetic separators the metals, copper and aluminum, and then you get this black mass and you can process it directly. Copper and aluminum, of course, have economic value and are completely recycled. So this is a proprietary in-house technology developed in Singapore. There are many others. Have a look at the chemical treatment, the new green chemical process. It works in water, so therefore you need water and some other chemical reactants, like for example hydrogen peroxide, but not toxic chemical reactants. These are the leaching chemicals. And you isolate graphite, which composes the anode of your battery, and eventually battery grade cobalt, hydroxide, and lithium carbonate. Everything is recycled, and the process is really environmentally friendly because there are no secondary contaminants. There are no noxious emissions into the air, into the atmosphere, or volatile organic compounds. It's very clean, completely circular process, a new green chemistry process in action. But before lithium-ion batteries get recycled, actually they are reused. So this is the Johan Cruyff Arena in Amsterdam. It's a beautiful stadium, relatively new, and it uses now almost 600 battery packs. 340 were purchased new, but 250 were second life batteries originating from the battery pack of a very famous electric car called the Nissan Leaf. Okay, when the capacity of the battery from 24 goes to 20 kilowatt hours, you get the batteries and reuse them prior to recycle them. Nissan was the direct supplier of the batteries. The batteries are repurposed. They're inserted in these battery racks. So you see, Nissan also certifies that the second life batteries will last 10 years. So before the batteries go for recycling, they will last at least 10 years in stationary applications, from electric mobility to stationary applications. You see, this is a real image of the stadium in Amsterdam. Electricity is collected from the rooftop. During the day, usually the stadium is not used, so all the electricity that is generated by the photovoltaic modules on the roof of your stadium feed the batteries. When the batteries are full, then you use all this energy at night when there are events, and the absorption of power goes from 200 kilowatt to more than 3,000 kilowatt in a matter of less than half an hour. Very simple technology, very efficient. It works very well since more than 2 years. So first question, are there enough lithium-ion batteries available now for profitable reuse and recycling? The answer is yes. This data are from the leading expert in Europe, Hans-Erik Merlin, who works in London, but he's Danish. For reuse, we have already something like 150,000 tons every year. We are here now. And available for recycling, we have slightly more, but if you look at the slope of these two curves, we'll have a lot of batteries available for use, all come from electric vehicles, and a little bit less, the slope of this curve is less pronounced, because these batteries for recycling include, of course, batteries from portable electronics, mobile phone, laptop computers, home robot, and so on. So does the world does the world has enough capacity to recycle the current output of end-of-life batteries? The current capacity of all plants in China, Europe, North America, and Southeast Asia exceeds 700,000 tons per year. This is enough capacity to recycle the available volumes that will be available in 6 years, in 2027, including production waste. So actually we have our capacity, the global capacity is much larger already now than the output of end-of-life batteries. What is this recycling capacity installed? The geographical distribution reminds exactly the pattern of production. 30,000, almost 31,000 tons per year recycling capacity in the European Union countries, almost 30,000 tons per year in the United States of America, and the incredible 707,000 tons per year in China alone. So think that this company, which is called Umicore, it's a chemical company that sells catalysts, metals, and so on. It is leading Europe's battery recycling. I think they're based in Belgium, and they have several plants in Europe. Their capacity, 7,000 tons, and the largest company in China has a capacity of 120,000 tons. But even in that case, Europe does not use its full capacity, because, for example, last year, 2020, we recycled 18,000 tons of waste batteries, and we exported to Southeast Asia and chiefly to China another 18,000 tons. If you look at the reasons why China dominates the battery market, have a look at this written testimony of Simon Moores, managing director of a company consultancy in London, that it was his third written testimony to the United States Senate last summer, okay? And he will show you that China dominates because they invested in the midstream chemical refining and the midstream cathode and anode production, something that we in Europe and in North America, we didn't do. So should we invest right now in battery recycling or reuse? Yes, it is profitable and convenient, but only if you have a deal with a company ensuring a prolonged supply of end-of-life batteries. Why? Because battery manufacturing companies, of course, are very much aware of the value, of the economic value contained in the spent batteries. So this is London, for example. The whole line 507 is completely electrified. This is an electric bus. The batteries are here, beautiful lithium ferrophosphate batteries. But if you think you will be able to buy the batteries in London, forget about it, because battery makers will take back the spent batteries directly from the owners, the electric bus companies, and they will recycle the batteries at their own plants, of course. So what is the best lithium-ion battery chemistry? It is a technology, very simple in chemistry, called lithium ferro, F stands for ferrum, Latin, it's iron in English, phosphate, okay? It contains no toxic and rare cobalt, no toxic and rare cobalt. 3 years ago, we wrote an article, and there we wrote, we forecast that the LFP batteries will remain the dominant technology for several years to come, because they are safe, they're long-lasting, and now they have also large capacity and lightweight. Those are exactly the batteries providing electricity to the electric bus in London. And now BAD, which is a large battery company, developed a battery called Blade battery. It uses only LFP, it works very well, and is set to revolutionize the electric vehicle market. So, is there a true information crisis when we talk about lithium-ion batteries on the general press or even in scientific journals? These are very recent titles from different sources of information. The rise of electric cars will leave us with a big battery waste problem, failure to recycle old phones, leading to shortage of vital battery materials, and so on. More or less, the press agrees that there is a crisis with recycling and reuse. Actually, there is absolutely no crisis. Lithium-ion batteries are already reused and recycled across the world at exceeding 90% rate. Less than 10% of batteries Most of them are small batteries from mobile phones and in landfills. And even in that case, the share, the percentage is rapidly decreasing because people are looking for batteries because it's so much convenient to recycle and to reuse them that they will pay the batteries, the spent batteries. So there's no way that the batteries will landfill in Africa or in Sicily or in less developed, economically developed countries. New green chemistry technology will shortly replace first generation pyrometallurgical recycling. There will be no burning, no fire, only green chemistry technology. And very often, information in the mass media, but also at times in scientific journals on new energy technologies, which include, of course, batteries, but also, for example, solar cells, is wrong, or very simply, is very much outdated. So thank you for your attention. This is Palermo, front sea, looking at north. Rome is here, let's say, and this is the old central Palermo. Thank you very much for your attention.
Thank you, Mario. Thank you for sharing the beautiful image. But more importantly, thank you for a very thought-provoking presentation. And certainly in encouraging us to challenge maybe some assumptions in relation to battery technology availability and future use. So we look forward to a discussion on that a little bit more in a while. So moving on, it's a pleasure now to introduce our final of the four panelists. So last but by no means least is Ciaran Gallagher from the ESB. Ciaran is the General Manager of Smart Energy Services at ESB. He's an experienced engineer and commercial manager who leads a team of energy engineers designing, leading and delivering decarbonisation projects for large energy users. Ciaran has experience working in many senior roles in the energy sector, covering power station management, asset sales, energy project development and delivery. Ciaran's goal is to help Ireland to meet its environmental targets by working with large energy users to decarbonise their energy usage. So over to you, Ciaran, please. Not sure if you're on mute, Ciaran, but I don't hear you.
Well, there had to be somebody that made that mistake, so fair dues.
Great, good stuff.
Thanks for the introduction, and thanks to Mario for a very interesting presentation there on the battery economy. I will try to keep the standard up as high as that. I'd be lucky if I do. So what I want to discuss is a project that ESB is involved in East Anglia in the UK. And it's an interesting application of electrification of heat for a commercial greenhouse. Just 1 second now. My slide are you seeing my slides at all moving? Sorry, no.
No, they're not moving yet. Do you want to unshare it and try and pop it up again? There you go.
Try reshare, sorry now.
Yeah, no worries. Okay.
Okay.
There you go. Great.
Thank you. Sorry about that. So ESB Smart Energy Services, which is part of the customer solutions business in ESB, has contracted with a company called Low Carbon Farming to deliver what we believe is Europe's largest renewable heating project, and it's to power 30 hectares of greenhouses in 2 sites. And those sites are, as I said, in East Anglia, in Norwich, and in Bury St Edmunds. We saw this as a gap in what we were able to offer a couple of years ago. So we acquired a heat pump development company in GB, and we've been using their expertise to develop projects on a smaller scale. This is the biggest one that we've done. Just some facts about the project. I guess it's the world's first design capturing waste heat, and we're actually taking the heat from an effluent plant. It's been 3 years in development, and we're in the 2nd year of installation now. We're currently in the commissioning phase. Hopefully that will be completed by mid-May. And for each hectare, we're using 10 times less water to produce 10 times as much crops as you would in conventional farming. It's the largest heat pump installation, we believe, in Europe. And as I said, there are 70 acres of greenhouses. They will produce roughly 12% of the tomatoes required in the UK. So it's kind of seen as a food security project in terms of Brexit, and obviously it's a highly renewable project, and all water that we use inside is recycled. It will deliver 360 full-time jobs, mainly crop growers and some maintenance on our energy centre as well. And it'll deliver a 75% reduction in carbon footprint when compared to conventional greenhouses. And the scale of the project, I'll show some photographs later on, it's vast really. There's 6 times more glass on these greenhouses than there is in the Shard building in London, if anybody is familiar with that building. So look, most people are, I'm sure, are familiar with what heat pumps are. So it's just a conventional refrigeration process. If anybody doesn't know how a heat pump works, just if you reach around the back of your own fridge or freezer, you'll find the heat being rejected there. And all we're doing is using the reverse of that. We're using that heat and delivering it to the glass houses. It's what we call a hybrid system. So the heat pumps are actually powered by a CHP, by a combined heat and pump plant. So although it is grid connected, it doesn't need to be. It's the grid connection is for pure backup. And an interesting aside here as well is that the CO2 and the exhaust from the combined heat and power plants is also delivered to the greenhouses for photosynthesis reasons. So it's quite a clever application. This is a schematic representation. So on the top left there, you can see the effluent plant. There are 2 sites that are similar to this, and we have a large heat exchange building built on the effluent plant where we take the wastewater from the plant and transfer the heat into our own fluid, which is then pumped up to where the heat pumps are. That's roughly 2 kilometers away. The heat then from those heat pumps heats the greenhouses to about 55 degrees. And as I said, the CHPs power that, and the CO2 from the CHPs is also delivered to the greenhouses. We also have a backup. The client insisted on having backup boilers in case there's any issue, because there's roughly £2 million worth of crops in these glass houses at any one time. So the loss of heat would be catastrophic. So there are backup boilers. Just in terms of scale, there across the 2 sites, there are 29 heat pumps at 2.1 megawatts thermal each. So there's over 60 megawatts thermal going into these plants. We have 5 CHP units delivering 6 megawatts to power them. And the gas boilers, which are backup, produce 27 megawatts of heat as well. So it's quite a high scale for this type of project. So this is just a photographic overview, and it's just to give an idea, I suppose, really of the distance between this. So the effluent plant and the heat exchange building is approximately 2 kilometers in each case from the energy centre, which is adjacent to the greenhouses. So it's quite a convoluted pipe run in each case. And in terms of scale, this is just a representation we use. It's under glass. You've 10 times the area of Croke Park, which is hard to imagine unless you actually see it. I'll just show some photos now of what went on. These are the actual heat pumps. So these are the 2 megawatt heat pumps. This is during a factory acceptance test. And the heat pump manufacturer is a company called Airmac, which are based in Genoa in Italy. And this all kicked off, if you like, at the start of the pandemic. So as Italy was going into lockdown, our heat pumps are just coming out of factory acceptance tests. So we were very concerned. We had to meet an RHI deadline for this project. So we had to send over trucks, more or less collect them under emergency situations and get them to the UK, just as Italy was going into a phased lockdown. So it was quite a fraught time in the project. We got there, and these are the heat pumps being delivered to one of the energy centres. I believe that's the one in Norwich. And on the bottom left, you can see the configuration as they're laid out in the energy centre. This is a more recent photograph. So as I said, we're in manual at the moment. We're doing commissioning. So the first crops went in January, and we even had our first delivery of cucumbers, I believe it was, there a few weeks ago. So the first crops were actually generated. So it's farming is or certainly this type of farming is not something I'm well up on. So we were quite happy to provide the heat, but the model is that the LCF, Low Carbon Farming, who are the contractor, they rent out space in the greenhouses to various growing companies, and they plant and manage their own crops. Our role is purely providing the energy centres and the heat. So this is just an aerial shot again, just showing the size, various elements on the left and Norwich on the right. So quite a vast area under glass. So that's the end of my presentation. Hopefully I've got you back on time now. I think I've saved a bit there. So thank you. And if there are any questions, very happy to take them.
Brilliant, Ciaran. That was phenomenal in terms of scale. So, you know, Mario left us with a beautiful image. You've left us with a totally different mental image, and quite extraordinary, really, in terms of the project that you've presented on. So, as I said at the start, you know, that this was going to be a very rich session because of its diversity. But within that diversity, there's that really strong thread of innovation, actually, within the context of energy and the circular economy. So I've been keeping an eye on the questions as they have been coming in. I suppose what we'll do is maybe go to each of the panelists one by one initially, and at the same time, though, really encouraging comments from other panelists if they'd like to contribute to any one question. And then I'll try and sort of join up questions so we can discuss a few general issues a little bit more. So I've tried to group the questions as I've seen them coming in. And Donna, actually, there's quite a lot of questions coming in relation to the district heating. And I think, you know, a lot of questions around how the type of initiative that you've shown in Dublin, how it could be transposed to a Cork scenario. So questions about different areas here, Cork Docklands, Little Island, the National Maritime College of Ireland campus, UCC, CIT campus, swimming pools and so on. So I don't know how familiar you are with the geography of Cork, but we'd love to hear your thoughts about how Cork can get in on the game in terms of the types of projects that you're involved in.
Yeah, I'm in the middle of doing a PhD in UCC in Marai, so I know the Cork area a little
Very
well
good.
enough. So I suppose the Docklands area, I suppose that's I think I've heard district heating, I suppose, talked about the Docklands area for a long time in Cork now. I think there were plans a few years ago. So the redevelopment, I suppose, I mean, if you take a comparison to one of the Dublin projects, like in the Dublin Docklands area, it's, I suppose, we're starting off there, particularly because it's around new developments. So one of your advantages of looking at new developments is, firstly, you know, you're looking at highly insulated new buildings, which require lower temperatures. And you're connecting into a system that does, you know, you're not replacing anything. So you're not going in and trying to replace a boiler or anything like that. So you're going into a brand new development. And it's much, much cheaper for developers. So we have queues of developers looking to connect to district heating in Dublin. It's much cheaper for them to meet building regulations by connecting to district heating, because they don't have, obviously, their on-site cost of like multiple heat pumps or large-scale heat pumps or CHP or whatever it is that they have to put on site. So they have it's a much smaller footprint. They just need heat exchangers on site, so they have more space for more apartments or more car parking spaces or whatever it needs to be. So new developments have those benefits. I wouldn't be 100% sure on the actual sources of waste heat that, you know, I would say doing a deeper analysis of the kind of the lower temperature sources available around the Cork City area, like in Little Island and those industrial estates around there, to see what's actually available. You are on a river, you know, so their water source based heat pumps would be ideal for a new development around the Docklands area. There's examples of that in Scotland, for example, where they're taking the river water temperature, which is at obviously higher temperature than ambient air, and then using that so you get higher efficiencies through the heat pumps. They would all have the you know, that they're the benefits of a new development. And then for the industrial areas themselves, like, you know, there is a lot of so what we find in industrial areas is you have one process that's trying to get rid of heat and another process right beside it that's trying to using fuel for heat, and they're right next door to each other. So it's looking at that industrial symbiosis in those industrial areas, so connecting the industrial users themselves and looking at how they can share those resources, how, you know, where a cold storage facility is dumping heat can be used next door in another facility, a food production facility or something like that. So they're the kind of potentials and I suppose that Cork can look into.
And Donna, just picking up on that thread for a second, you know, you said at the very beginning that Ireland is using less than 1% of you know, district heating as an opportunity. So we're slow to the game compared to our European partners. Can you just give us a sense as to where we are nationally? So we've got a sense of the, you know, what's happening in Dublin in terms of the projects that you're leading on, but you know, is it that local authorities, who needs to get involved here to profile what the competitive advantages of any one area might look like? So in the case of Cork, who needs to come together to actually turn the dial a little bit on this?
Well, I suppose because we are quite new to it, and I suppose without a kind of a lack of a national body, let's say, to roll out district heating, or, you know, which is kind of what kind of would need to happen, like somebody there to guide and, you know, give guidance, you know, provide low cost funding, and that, you know, have that kind of facility there, and to help to kind of roll out a district heating is what we would really need to kind of get to the scale that we need to get to by 2030, you know. Now, but in the interim, I suppose local authorities are definitely the, you know, definitely the kind of players on the ground who can have a very high influence on this. So first, future-proofing the demands and future-proofing the supplies. So through your planning systems, through the local authority planning systems, looking at how you can get developers to start thinking about district heating and putting in, you know, planning requirements for them to, you know, consider district heating and connections, and also any industrial developments that are producers of waste heat. So making them make sure that they're future-proof to connect. That's how we got the data center, for example, in Tallaght to connect to the district heating system, was because it was through the planning process, it was through the planning requirements that they had to have the district heating connection there. You know, they had to be able to connect in. And then again, in the Dublin area, we've you know, in the Dublin city area, we've planning requirements that all the new buildings in the Docklands area have to be district heating enabled. So these are key kind of roles that the local authorities can play, I suppose, now to start future-proofing for district heating rollout. And we have seen a big increase in the interest at a national level for district heating. So in the new climate action plan, we've been feeding into that on district heating. So there's going to be an increase in the targets for district heating. The national planning framework already states that, you know, they're looking at rollout of district heating in the 5 kind of key cities, so Galway, Cork, Limerick, Dublin, you know, in those kind of areas. So it's not just concentrated on Dublin, but I suppose the Dublin projects are like the pilots to kind of help overcome the barriers and that.
And what's, just to finish up, in terms of the target for 2030, what should we be looking like ideally, from 1% to?
Ideally 10%, and it's yeah. So, and it's not like, that's not a figure we pulled out of the sky. If we look at what the Danes, the Finns, and the Swedes all did back in the 60s and 70s, they got a 1% increase per year, in those, you know, each year to the kind of percentages right now. So if we can't do what they did back in the 60s, I think there's definitely something wrong. But yeah, so that's the target that we're going for 2030, is 10%. And
I suppose it all starts with education and awareness and forums like this to plant the seed and for new opportunities to emerge. Okay, there's a couple of other things, but if I have time, I'll come back. But I think what we'll do is just move over to Niall. And Niall, a couple of questions came in relation to, actually at the start of your presentation, you talked about the business and the work that you're doing in training and education. And that's something that got picked up by a couple of the questions in relation to what exactly needs to happen in terms of training up of architects and builders and contractors to actually make sure that we're making progress with regards to our built environment here in Ireland.
Okay, it's something we realised very early on when we began importing materials and training people, that training was crucial both for specifiers and for the builders. What we've seen over the last 2 decades now is more and more bodies delivering training, like the Irish Green Building Council, for example, on their website. They have a number of courses they're running for specifiers in terms of life cycle assessment, retrofit, and other areas. Suppliers such as us, we deliver our own training as well, and there's a full suite of training courses on our website. And now you also have, for builders, we have a training centre, but also you have a national programme now with ETBs, where there are training centres set up in the southeast, in the Midlands, in the west, and throughout the country. And that's in development in these ETBs for training builders to upskill them into NZEB, into good principles for retrofitting buildings as well as in new builds. So putting a fabric first approach in buildings, air tightness detailing, appropriate detailing for insulation, and so on. So there is a huge amount of education and training there still needed. But there are programs both for builders and for specifiers. The RIEI also have a number of courses and CPDs they run on their network, as well as Engineers Ireland as well. So yes, there is a lot of education there. There's a lot done, but yeah, there's a lot more to do as well. But there are more and more training courses available compared to 10 or 15 years ago. Now there's an abundance of training both for builders and for the specifiers. The big challenge I find, the silver lining with COVID, if there was one, is what we're doing today. The ability to bring specifiers and people together to review projects more efficiently and to educate and train. Yesterday we did a training course with over 100 people online from Ireland and the UK, and it went very well. The struggle I find is when things get busy and ramp up, how do you motivate builders and skilled trades to come and get training? Because they're so busy, they could be earning their money and could be working. So try and get that window of how do you deliver training to skilled tradespeople and give them an incentive to upskill. So that is a challenge, but there are more and more courses available than ever from numerous bodies now for upskilling and training.
So it sounds like the tide is turning in terms of the supply side and the skills and the capacity to deliver. What about the demand side then in terms of the developer, whether it's just yourself in terms of your own home or, you know, somebody that's developing a new office block, whatever it might be. So what about the cost side and any incentives towards, you know, really ramping up on this with regards to cost profile and how it compares with the traditional costs?
Well, in terms of cost to build to an NZEB standard and building to these levels of performance, the good thing in Ireland compared to, say, the UK, for example, where we've a lot of input as well, and to Northern Ireland, is we've had a gradual increase in our building standards. We haven't seen a huge step change. So since 2011, we've seen a step increase in our requirements for compliance with Part L. So proportionally, there is an improvement every year, but say for NZEB compared to where it was, it's estimated that it's about, I forget the figure, but there is a figure, I think it's about 4 or 5% increase on the previous standard, an additional cost. What we're seeing more and more though is, for example, with passive house levels of performance, where a fabric first approach is taken very much, there's almost there's numerous studies now showing that the current NZEB standard to passive house, especially when built at scale, there isn't a huge differentiation in premium. So it's our actual national standards now for NZEB in domestic buildings is to quite a high standard compared to our international colleagues. In terms of training,
that's an important message, really, isn't it? To get out there. Yeah,
it is.
Yeah.
I was at a conference in Frankfurt 2 years ago at an international passive house conference, and I was speaking to colleagues from New Zealand. And when I explained to them about this very discussion about the national standards and what our minimum standards are compared to New Zealand, we're much more advanced. Or I regularly deliver training to our UK colleagues, and our backstop U-value requirements, our average air tightness levels we're achieving on buildings in Ireland, and the development in Ireland of the building industry. For example, if you Google air tightness installers in Ireland, you get a list of page after page of installers, whereas in the UK it's very limited. So I think our industry is more evolved. We knock it sometimes, but it actually is quite evolved and developed, but it can be tailored and improved all the time. Yeah, so that's
just there was a couple of sort of questions that came in specifically on some of the materials. So one in particular, for example, in relation to the hemp and the wood fiber products, whether they're flame retardant. So I think that question of, you know, durability and safety seems to sort of come across a couple of the questions on materials. It'd be good to speak to that for a second.
Okay, yeah, and all the materials comply with their relevant harmonized EN norms. So the wood fiber and the hemp, for example, hemp has baking soda added to it, which gives it the fire retardants needed for compliance with the building regulations. Likewise, recycled cellulose has borate salt added to it, and again, that's to give fire resistance, and similar to sheep's wool, and similar for wood fiber board. So in terms of compliance with building regulations, they all comply with that in terms of the requirements to comply with Part to the harmonized norms. In terms of durability, the materials are exceptional. That's one of the actual benefits in terms of their superior durability in different scenarios. But every material has limitations, and I'd often say a material doesn't fail project or people fail materials. So if you take any material and put it in the wrong situation or environmental condition, it will eventually break down if it's not designed for that location. In terms of the wood fiber, it's been produced since the early 1930s. Since 1932, they've been making wood fiber insulation, and there's still buildings using it. I recall vividly a retrofit of a house in Dublin, which was built in the 1930s. And when we stripped the walls, wood fiber was still on the wall and was perfect. It was hardboard wood fiber on the wall when they were stripping it, and they were replacing it with more wood fiber. So as a raw material, natural materials are actually very resolute and resilient. Hemp is another example. Hemp, they've used it for millennia and for centuries in paper or in the sea and the boating industry. Hemp is used as ropes in the sea, in sails, because of its incredible durability and resistance to moisture. So natural materials are actually very, very resilient. But of course, like anything, it has to be used in the right context.
Excellent. So huge amount of advantages, you know, in terms of the passive house, the materials, and not just in terms of being able to sequester carbon, but for lots of other reasons too. Yeah. All right. Thank you. I'll skip across and hopefully maybe come back to you again and try and get to a couple of the other questions if we have time. We'll go over to Mario, please. And Mario, first question. I think it's in relation to why the mixed messaging in relation to the mass media and the scientific community in terms of battery pollution. What's driving that?
It's very, very common, not only in Anglo-Saxon countries. I showed you titles, headlines in English. I could do the same in Italian or in Spanish. Things in matters in the field of new energy technologies go very quickly, very fast. Therefore, information very often is outdated. 10 years ago, maybe we didn't have enough recycling capacity. But since the Chinese knew very well that those materials within lithium-ion battery are very much valued, and also they knew that, for example, they don't have enough supply of lithium, therefore they need to recycle lithium to make new batteries, because of course the customers of the battery recycling plants are directly the battery manufacturers. I showed you the largest recycler in the world is called Brump. It's in China, but it's completely owned by the world's largest battery manufacturer, which is called Gartland in China. So it's very convenient and very easy to understand.
So it's vested interests at stake here by the sounds of it. I think Mario has frozen. Is that just happening with me?
No, he's frozen on my
He's frozen.
Let's,
okay, that's a pity. Hopefully he'll unfreeze, but we won't pause. We'll segue across to Ciaran. And Ciaran, a straightforward question first, in terms of what powers the CHP plant?
So the CHP plant is powered by natural gas, by grid gas. And look, that's very much down to the client's choice. They wanted electric connection and the gas connection for backups. In many ways, you could argue that like the grid in GB, it's quite low in carbon intensity, much more so than the grid in Ireland. In fact, last year, I think it was its lowest ever year of carbon intensity, and it was down to 140 grams of CO2 per kilowatt hour in the month of May 2020. But no, it's powered by, the CHP is powered by gas. It's more for resilience than anything else.
And then to come up to 30,000 feet in terms of the strategic outlook, 10 years from now, what will the world look like in terms of the nature of project you've just described? I mean, it's so hugely influenced by innovation. It's so impactful in terms of scale, in terms of the whole integrated system. What's next in terms of innovation? 10 years down the road, where does it go? How does it look?
Sorry, Val, I didn't hear to start. Were you talking to me at the start there? I didn't hear the very start.
I am, yeah, Ciaran, I'm wondering, just it's such an innovative project, and in every way, and it's such a project of scale and of impact. And I'm just wondering, where do you go from here? What does
so,
the future look like? So just cast 10 years down the road maybe, and give us a word.
So just a couple of things worth noting about that project. It is vast, and one of the things that made it work was that it's supported by the RHI scheme. Now, RHI is a very dirty word in Ireland for historical reasons, but it wouldn't have happened without that support of an RHI scheme. Now, we have done other smaller scale projects under RHI as well. There's a very interesting project up in Dundee, you might see online, with the V&A Museum, where again it's heat pumps, electrification of heat, and storage of heat actually in the ground beneath, in the rock structure beneath the museum. The heat is stored and recovered. So those are the type of projects that we're looking for. Smart Energy Services kind of works with large energy users. So large industrial customers are large buildings, public buildings, and we would love to do some of those type of projects in Ireland, but there isn't the same traction, unfortunately, in Ireland as there is in GB. And that's largely due to, I think, supports. Now, there's CapEx support in Ireland, all right, that will get you so far, but some of these projects need operational support, ongoing support, and that is the dilemma. The Dublin district heating scheme is a very interesting project that we're all very hopeful to see that going. It's a little bit different to electrical heat projects in that it's using waste heat from a power station, and obviously the dilemma with power stations is that they're not always online. Now, obviously with the Covanta plant in Dublin, which is an energy from waste plant, its whole modus operandi is to burn waste. So it has to process, I think it's 600,000 tons of waste every year. So the availability of that, the only risk there is the availability of that plant, and it's generally quite high. So it's up over the 90%. But it's a different, you're at a higher temperature waste heat then, so it doesn't quite match with heat pumps. So it's different. And I think in Ireland, obviously Dublin is a good area, and we discussed Cork already. I suppose one thing in the future is this idea of ambient loops for heat pumps, and that's where you take something like river water, you pump it through a loop through various customers, and they hook on their own heat pump and upgrade the heat. So that's one way of generating scale. And like the big risk with a lot of these heat projects is the customer, basically, and the viability of the customer. So obviously with large industrials, sorry, yes, Val.
Sorry, no, carry on. I didn't mean to cut across.
I was going to say with large industrials, you can do a health check, and you know you have a customer and certain amount of resilience. When you're dealing with private tenants, there is more risk there, and I guess that probably is one thing that always stymies these projects. I'm sure Donna knows far more about this than I do, but that's just, I guess, an industry view of the sector. From a company that is not that well versed in heat projects, to be quite honest. Like we're only at the starting out of it, certainly in Smart Energy Services.
Yeah, it was a surprise to me, and maybe it was to others as well, to see the ESB bang smack in the middle of a project like this. I can see now that you've presented it and discussed it. And it's fantastic.
It's a supreme irony for me, because I spent many years of my career in Moneypoint, where a good year in Moneypoint was generating 5 million tons of carbon every year, and that was the industry we were in. So obviously Moneypoint is being phased out now, and things are changing, and ESB is Bright Future strategy is all about decarbonising. So that's why we set up this business, to try and help and drive that.
And I'm conscious of time, but I do want to ask you, when you look at the project, going back to the project in the UK, it's a win for climate, it's a win for the environment, it's a win for food productivity and food security. But it's a large scale project, and people often don't like change. And it's so important to have a win with the community, and to bring the community with you on any kind of a project that is in the area of energy and circular economy. Was there much support from the community in terms of the project, Ciaran, or any objections?
No, the UK is interesting. You don't tend to get the same level of objection as you do in Ireland. Like certainly we have done things in GB that we couldn't countenance in Ireland. There's a much more, I think the planning process is a lot more efficient anyway, and certainly the way objections are managed and dealt with is better. Like there are a lot of energy from waste plants in GB. There's only, I think, 2 maybe 3 in Ireland at this stage. 32 that I know of, and one in development. It's very difficult to get to even wind farms in Ireland, which you think would be the most renewable technology that's there at the moment, and they're difficult. Like you always have problems with objection, and people are entitled to object, obviously, but there's more scope in GB to get projects off the ground, and less risk for that reason.
Cultural issue question there. And speaking of culture, I'll jump back over to Mario, because I think he's live again. Am I right?
I'm live again. Sorry.
You are, you're there. We'll jump back across. And you know, we were discussing the question of vested interests in the whole battery industry, and I suppose the conflict of interest between the manufacturer versus those that are driving the circular economy dimension to this. So there was a question about the policy side and policy interventions. You know, for example, we saw Europe is exporting waste batteries. I think about, what did you say, 17,000 tons or so, and recycling roughly the equivalent. So, you know, if we don't see Europe getting its act together and setting in train a coherent policy for how we're going to be more proactive in this regard, you know, it can be a challenge to think about how that can cascade down to national and even local levels like we're talking about here today. So maybe just talk to us for a second about what policy changes need to come about in Europe.
Well, policy in Europe at national level and also at, let's say, European level are very well developed. For example, let's take Ireland. Ireland has a lot, of course, of wind power installed, also offshore wind power. So all this power, all this electricity, very often is generated at night when people mostly sleep and consumption are low. So installation of large battery packs, which are called energy storage systems, is ideally suited in Ireland, but also in the UK, for example, or in Denmark. And those systems are already being installed right now as we speak, because governments, of course, know very well, and electricity companies know very well, that batteries magnificently work to regulate the grid. So you have power immediately available to restore the frequency of the grid, which is very important for the stability of the grid. And we all know these achievements from many examples from across the world. There is a large Hawaiian island that since 2 years generates, let's say, some 15% of its electricity needs from a large PV park installed within the island, and they have a large energy storage system, and which supplies electricity at night when the consumption at evening, let's say, when consumption is high and production from the PV plant is absolutely non-existent, no? Because the PV converts only sun power when there is sunlight. So these systems work very well, and there are incentives to install them across all European countries, even Russia. Even in Russia, they're installing those systems in part of Russia which are not connected to the national grid. In Siberia, not only in Siberia, in the north of Russia, close to the Arctic Circle, these systems work. They work splendidly. They're absolutely reliable and very convenient for electricity companies. So policy is not really an issue. The only issue in Europe with the batteries is production, is the chemical companies which did not invest in battery production. So they thought it was a doomed technology. But the reason is very simple. Chemical companies are petrochemical companies. Then the answer to your question is very simple. Vested interests are in oil.
Thank you. And I think, you know, what you're coming to there is a point of interest in terms of just listening to all the presentations. We're certainly not at a stage where we're waiting for technology. You know, the technology is here. I think that's what I've heard really loud and clear across all of the presentations this morning. It really is now about having the wherewithal and the capacity as a society to just seize the moment and act with the urgency that we need to act on in terms of rolling out this technology and creating the new world order that we need to see because of the issues that are driving all of this. So those huge challenges and huge crises that we face with regards to climate and environment. So I think in the interest of time, what I'll just take a moment to just reflect on the fact that going back, it seems like a long time ago now, but we heard from Donna, you know, huge opportunities in terms of district heating, you know, 1.6 million homes potentially in terms of the waste heat generated in Dublin alone. Some fantastic figures from Niall, and I really was struck by, you know, that we're going to be doubling the number of buildings on the planet over the next 40 years, and the equivalent of building in New York City every month over the next 40 years is quite phenomenal. And equally in terms of Ciaran, the 6 times more glass than the shard in his greenhouses, covering a spatial footprint 10 times the size of Croke Park with heat pumps. And hearing from Mario in relation to the chemical process that can be used to recover lithium-ion batteries. And you said at the start about keeping it simple and straightforward, and you gave us a great insight to chemistry there that was very digestible even to the likes of myself. So thank you all for spending such time to create such excellent presentations to deliver your messages, which were delivered with such passion, but also really well in terms of the quality of the presentations and the timekeeping too. It was a privilege to get to facilitate this session. So that's it from me. I'm going to hand over to Harry O'Farrell from Energy Cork to close the session. Thanks a million.
Thanks, Val, and all. So some fantastic insights from everyone participating there. So look, thanks very much to our speakers today, Donna, Niall, Mario, and Ciaran for your time, effort, and insight. A big thanks to Val Cummins for moderating the session and the Q&A. Thanks to Cork Chamber for sponsoring the conference over the last 3 days and tomorrow as well, obviously. And as ever, thanks to Cork City and County Council for their continuing support via their economic development funds. Most of all, thanks to you all for tuning in. Fantastic numbers in attendance again today, and engaging with the discussion. Some fantastic questions coming from members of the audience there. Look, if you have any feedback on the event or want to learn more about becoming a member of Energy Cork, don't hesitate to get in contact with Ciaran, myself, or Michelle. Most importantly, we're looking forward to tomorrow's final session, session 3, the circular economy and the just transition. Our moderator, Tara Shine of Change by Degrees. We have Brian Ledden, TD, Chair of the Oireachtas Joint Committee on Climate Action, Dr. John Riley of Board Namona, Georgina Foley of Green Rebel Marine, and Elizabeth O'Brien of Limerick Institute of Technology. Thanks again to everyone for attending, and we hope to see you all in such numbers again tomorrow.